Hello everybody and welcome back to Operation Logistics, where we are currently, in the middle of making our pathfinding system. And first we need a way to convert from a list of int3s to a list of buildings. So let's just go ahead and do that quick. So to convert this to a list of buildings, the easiest way would be to just do list building return list equals new list building. And then we're just going to iterate through this list here, but we are going to return list. Okay, and then for each int3 location in that list, we will go ahead and do manager.business.hexmanager. Or actually, hang on. We're going to do return list add manager.business.hexmanager.getBuilding by index, and then we just pass in location. Easy. Okay, so there we go. We are expecting another parenthesis there. There we go, perfect. And then we hop over to our pathfinding algorithm right here, and I kind of have my reference on the other monitor. The wrong monitor. So there we go. That was a little awkward, but it's fine. Okay, so we are not removing at 0. That's one thing that we are definitely not doing currently. So then we just need to, let's see, for each building in current.neighbors, I just need to find where we were here. So that's here. Gotcha. So we were determining if it was walkable or not. I think for right now, we're going to go ahead and say if, and then slash asterisk slash for a block comment here. And we're just going to say if building.walkable in comment. I don't know if we're going to uncomment that or not, but for now, that's what we're going to do. So if the building is walkable, and the and actually needs to be in the comment. There we go. And not closed list hash dot contains. We don't need an asterisk there. Building. So if it's not on the closed list, then we're going to continue here. And we already actually have this right here. So what I'm going to do is I'm going to just copy this here. There we go. Next, we need to make sure that it's not on the open list. So if not open list hash dot contains province, and by province, of course, we mean building. Building. There we go. So if it is not on the closed list and it's not on the open list, then this is a completely new building that we have not considered in the slightest. So we need to go ahead and add it to the open list. And we add building, and then we also need to add it to the hash list, open list hash. And again, the hash list is simply essentially the same thing as the open list, except we use it exclusively for checking to see if it contains, because it's so much faster than searching the entire list. Then we can go ahead and say building. Wow, I cannot type this morning. Building.pathfindingParent equals current. There we go. So that's set right on in there. And then simply building.g equals current.g plus 1. Because remember, g is the distance that we've traveled along the path to get here. So that gives us the shortest possible path. Ish. We use some heuristics and it won't be exactly the shortest possible path, but we're about to do that here. So then building.h equals get distance to make sure that it's as close as possible. And then we go ahead and do from and to. So this would be building and to. So from the building that we are currently considering to the new building, and we do need to pass in our hex manager. We'll go ahead and do that. And then finally, building.f equals building.g plus building.h. And of course, if we hop over into the building, as done in the last episode, when we do the F here, or rather when we do the G, okay, it's in the G. Is that okay? Pretty much, yeah. I think that's fine. But I'm gonna bring that down, not 32F. I'm gonna bring it down to 2F. Okay, so we hop back in here, and we have all of this set up. So if it's not being considered, then we should consider it. Otherwise, if it is being considered, we should go ahead and determine if this is a better path to that building than the one that we've already considered. So we'll go ahead and do a float gtemp equals current.g plus 1. And then we'll check to see if gtemp is less than less than building, I cannot type, building.g. And if it is, then we will go ahead and say that this is a better path, and building.pathfindingParent equals current, building.g equals gtemp, and building.f equals building.g plus building.h. Okay, so here's the core problem here right now. Currently, the way we have this implemented is that this is always going to return true, pretty much, if this is not a road. So what I'm thinking right now is we should go ahead and add in an entry cost. So let's go to our building here. And for right now, we're going to revert G back to just this. And we're going to copy all of this, and we're just going to do that. And then we're going to do public float entry cost. And then we'll do a get, and we don't actually care about a set. And we don't need two gets. Okay. And then we just bring this on over. And then we'll just return 2. And then we'll return 1 if it's not a road. Well, if it's not equal to road, return 1. Otherwise, return 2. Okay, there we go. Now, every time we add the F, we're also going to do plus from.entryCost. There we go. And then we put that in here as well. And this should be building.entryCost here and here. Perfect. Okay, and we are now done with that for each loop. Excellent. And we're actually almost done with this pathfinding algorithm. So the next thing we need to do is say for each building in closed list. We just need to iterate through and remove all of the parents. We managed to break out of this while loop, right? Yeah, that's where we need to be. We actually need to be down here. So we managed to break out of this while loop. There's nothing left in the open list. It has checked every province that is connected to the province. It has checked every building that's connected to the one we specified. There is no route. So we, at this point, just need to clean up. So province, I keep doing that. Building.pathfindingParent equals null. And then for each building in open list, which at this point there shouldn't be anything in there, building.pathfindingParent equals null. And then all we need to do is path. No, what do we call it? Oh, we didn't call it anything. There isn't a path right here. What am I talking about? All we need to do at this point is debug.log error. And that's simply going to be pathfinding.pathfind Path failed, no connections found. And then return no. And there we have it. There's our pathfinding algorithm. Excellent. Now, we haven't done a pathfind on water. That's pretty much going to be the same thing, but only with world hexes. That's essentially what we're going for there. Now, the next thing that we do need to do, as I close out the old version, there we go. The next thing that we do need to do is check our get nearest hex, which I believe was in roots, a root. We've got update path here. So, I mean, realistically, all we need to do for update path is we need to get a list of vector 3s, pretty much. That said, I do want it to be just in the single list of vector 3s. I think we can go ahead and ditch the origination point, and we can just say position 0 in waypoints is the origination point. There we go. So we'll do something like that, and then all we'll need to do is something along the lines of for int I equals 1, not 0. No, I can't type. Wow. There we go. I is less than waypoints.count. I++. And then we will go ahead and say... We will go ahead and say list vector 3 partial path equals, and this will be pathfinding.pathfind between waypoints I-1, which is why we started at the index of 1, and waypoints I. Now, we don't have access to Hex Manager on the route, do we? We'll go ahead and get it. Private Hex Manager void start manager equals game object dot find object of type Hex Manager. There we go. And then we'll pass in the manager. So that gives us our partial path. Of course, these are vector 3s, not buildings. Oh boy. Right. Uh-huh. Well, that's a little awkward. Why are we converting everything to building? Well, we actually do need that, because we need access to the FGH. Yeah. So that's going to need to be a thing. So we're going to need to do manager.getBuilding, or rather, get building by position? We have that? I don't think we do we? Well, we've got get nearest hex. That gives us an int 3. Let's see here. Do we have one? We pass in a vector 3 and get an int 3. But I don't think we have one where we pass in a vector 3 and get the nearest building. We've got get nearest hex, which we can, once this is implemented, we can use this to get the nearest building. So then public building get nearest building vector 3 pose would then return get nearest hex position, but we'd need to then pass in the get building hex by index. and then pass in this as the indices, like that. And that's not... that returns building hex. No, we want to just get building by index, not building hex by index. There we go. Okay. Now this isn't implemented, so it isn't going to exactly work just yet. But that's okay. So then we'd want manager.getBuilding by, or get nearest building of this, followed by manager.getNearest building of this, like so. We need this closing parenthesis in here, though. Perfect. Okay. Okay, and then pretty much all we need to do from here is we have our partial path, and then we say, well, we do need path to be a new list vector 3 up here. So when we do update path, first we should do path.clear to make sure that the path is completely cleared. And then all we need to do is for each vector3 v3 in partial path, we will just go ahead and path.add v3. And now that will get us all the way to the end, but that won't loop us back to the origination point. So we should go ahead and do that quick and say list vector3 partial path equals this, except we want to be grabbing from the very last one. So waypoints.count -1, because that's 1 indexed. And then we want to be going to waypoints 0. Now we've already got partial path declared, I think, so we just need to do that, right? No, it doesn't exist in the current context. We're gonna need to name it something else, I guess. We'll call this the retread path. There we go. Okay, and then we'll just toss in for each vector3 v3 in retread path, path.add v3. Okay, and that will update our path. Excellent. So all we need to do now to really have the core of this implemented is in our here. In our hex manager, implement get nearest hex. But that is something for another episode. See you all next time.